be in after your term test. Okay. So from here, we know that we have 40 times 10 to the power 3 plus by by minus by the equivalent load is 160 times 10 to the power 3 go to 0. So therefore by will be equal to 40. Wow, so 160 minus 40 equal to 120 times 10 to the power 3 Newton. So far, very straightforward formulation. You are very familiar with it. Okay. So the next thing is we want to find, right? We're going to generate a table first. Okay, we're going to find the shear force and bending moment at specific points and in a certain range. Okay, so we're going to find shear force and bending moment a relationship at specific point and range. Okay, so what some of you might say, Eugene, what do you mean by specific point and range? Bear with me, okay? So we're going to generate a table. Okay, we're going to generate. So we're going to look points. Okay. So we are going to divide this structure into very specific points or range. Okay. So we're going to start from left to right. So the geometric datum, right, is always on the left-hand side. Okay. The geometric datum is always on the left-hand side of the structure. Okay, so this is our geometric datum. Okay, so our geometric datum is always on the left-hand side. Then the points that we look at is we will look at point A. Right? So we have done point A. Then we are going to do from point A to point B. Okay, point A to point B. Right? Then we're going to deal with point B. Then B to C. Okay, I just draw a straight line. It's B to C. Right? And then we are going to look at what's going on at point C. And then we're going to do from C to D. And then we're going to look at point D. Okay. So one thing I like to show you guys, okay, next is the limits. Okay, because we are going to form equation, we have to know the limits. At point A, okay, x is equal to 0, right? That's our geometric datum. From A to B is 0, x to 0.8. Okay. At point B, x is equal to 0.8. And as we know, everything is in what? Is in meters. Okay. Then from B to C, right? So if you look from B to C is 0.8 to 3.2. Right? So 0.8 to 3.2 is our range between B to C. Then at point C is x is equal to 3.2. And C to D is 3.2, x to 4.0. And at point D, x is equal to 4. Okay. Then we're going to have another table. Right. So this table, we will have our shear force as a function of x, which will be forming the equation. Okay. And then at next one. Another table, another column is m as a function of x. Okay. Now, a thing to take note is this. Okay, I'm going to have another, and this is important. A lot of times students get confused. Okay, this is foundation. No doubt you don't see it now, but later chapter you're going to see the effect. I want you to watch this. Whenever x is a specific number, so x is equal to 0.8, 0.8, x is equal to 3.2, x is equal to 4, all your shear force and bending moment diagram, it will be a constant. So this is a constant. Because why is it a constant? It is at a specific what? Location. I repeat again, it is a constant because it is a specific location. So constant. Now, then you see you have a range, right? A to B is a range, B to C is a range, C to D is a range. Then when that's the case, that's where you are going to write an equation. Okay, we're going to write an equation. Okay, so from here, anyone, any question for now? Is this clear? Anyone?
I have
Yes.
a question.
Yes.
Is that shear force that we're calculating on the x direction or in the y direction?
The shear force is in the y direction.
And the moment is moment around z.
Yes.
So
Y, V, the V over there is V as a function of X equation, not Vx.
got it. And the moment is also a moment.
As a function of X. Okay?
Got got it.
Okay.
That's where I was
Okay.
confused.
So the next thing that we're going to do, okay? So we are going to look at when A, okay? So I'm going to, again, I think it's good that we have this diagram. Okay, I'm going to paste the diagram on the next page. Yeah, I'm going to string the diagram. Okay, you can see the diagram next. Okay, so I'm going to, so this is where the diagram is. Okay. So this is the diagram that we're going to look at. Okay. So we are going to look at point at point A now, right? Because the table says that we have to find A first. So we're going to find it. So at X, at point A, okay, at point A, X is equal to 0, right? So if we draw our free body diagram, okay, so we're going to construct, every time we analyze a section, we're going to construct our free body diagram. We have a very narrow strip. It's a very finite strip because X is equal to 0. Okay. So this is on the left-hand side. Okay. This is where our datum is. Okay. That's our datum. But remember, at this case, X is equal to 0. And then X is moving over this side. Okay. So at X equal to 0, what we have over here is we have a vertical, we have a distributed load, right, which is equal to 50 times 10 to the power 3 multiplied by X. But because it's 0, right, you don't have any force. But the next thing is more important, right? Bear with me over here, right? So we are looking at point A down here, right? Remember, what we are finding now is a constant. So your shear force will be going down here. And your moment will be acting anti-clockwise. Okay. So what we are doing from the datum, right? We are doing our analysis from left to right. Okay. We are doing our analysis from left to right. So from here, we are going to, sorry, you guys will ask me, Eugene, what sort of analysis? I forgot to write something, okay? So we are going to do our static analysis. Okay, from left to right. So positive is going up. We follow our notation. In the y direction is equal to 0. So we have minus 50 times 10 to the power 3 x minus by v of a. This thing will be equal to 0. So v at point A is equal to 50 minus 50. Okay, sorry, minus 50 times 10 to the power 3x, right? And we know x is equal to 0, right? So we know x is equal to, so we're going to substitute x is equal to 0. So v at point A is equal to 0. Okay. And then we're going to have some mention about moment. Z at point A, right? This thing will be equal to 0. So when you take moment, right now, over here you can't really see it, but when we do the next range, you can see it better. I'm just going to write the equation now, okay? So I know some of you may be, why is it that way? Okay, as I say, you can't see it yet because it's a red thin strip. At point A, it's a straight line, you cannot see it, okay? So the equation will looks like this. So this will be going clockwise, anti-clockwise, 50 times 10 to the power 3, okay, multiplied by x. And then the distance, so this is the force, okay, multiplied by the distance, right? X over 2 is going in anti-clockwise direction. And then we have a moment that's going anti-clockwise, is moment about point A is equal to 0. So from here, we can write out that moment about point A is equal to minus 25 times 10 to the power 3 x squared. Then we're going to substitute, right? We're going to substitute x is equal to 0. We found that moment at point A is equal to 0. Okay. So once you, so like what I told you before, because it's at a fixed point, the x value is fixed. That's why all these are a constant. Okay. So we will go back to our table. I'm not going to do this very often. Okay. So we'll go back to our table. We will come here and say this Vx is equal to 0 and Mx is equal to 0. Okay, like what you could see now. So now we're going to look at between point A to point B. Okay, so point A to point B is going to be more obvious now. Okay, so now you cannot really see what's going on. Why this sort of direction? Okay, why moment is going down and why moment is going anti-clockwise. Sorry, I should have done this earlier. Okay, so for now, you'll be asking Eugene, if 50 times 10 to the power 3x is going down, why VA is also coming what? Down. And why MA is at that direction. That's what I'm going to explain now. Okay. So let's for me to explain this clearly, I have to look at a range. Then it will be more obvious. Okay. So the next one we're going to look at range. So this is between.
Ying.
Yes.
I was just wondering, for the moment.
Can you hold on? Let me explain the next part. Then it will answer your question. Okay.
Okay.
Can you wait for a moment? Okay. So between point A to point B, where you have 0, x to 0.8. Okay. So we are going to construct our free body diagram now. We're going to construct our free body diagram. So I'm going to I'm going to draw our free body diagram. I'm going to draw it big. Okay. So this is where our geometric datum is. So this is for point A.